This is the solutions video for problem set 12 for Kevin Ahern's BP450 class at Oregon State University. The first question of the problem set says, imagine you suffered a mutation that caused your body to be unable to break down prostanoids. Based on the processes described in class, what do you suspect would be the result of this, and how would you treat it? Well, from what I've said in class, prostanoids are involved in two main things. There are other things they're involved with that I haven't talked about. But the two things I have talked about are that they're involved in localized pain. They're also involved in the production of important molecules called thromboxanes. With respect to the production of pain, the pain is fairly localized. I talked about a bee sting having prostanoids being produced very locally and causing severe localized pain. If prostanoids were stabler, one might expect that they would travel further from their point of production and cause other things that would happen, like, say, an increased amount of pain. With respect to With respect to thromboxanes, prostanoids are the precursors of them. One would expect that if one had stabler prostanoids, then one would be producing considerably more thromboxanes. This would probably be fairly detrimental to the individuals because thromboxanes are involved in the process of blood clotting. So increases in the amount of thromboxanes would cause a pretty significant increase in the amount of blood clotting, and that could pose a problem for things like stroke or heart attack. Question number 2 says, your friend says her doctor told her that cancer is caused by proto-oncogenes. What do you tell her? Well, the primary thing you should tell her is that the doctor needs to get the nomenclature together. Proto-oncogenes are normal, unmutated genes that are responsible for signaling and control processes inside of cells. They do not cause cancer. Mutated forms of proto-oncogenes, however, are known as oncogenes, and these oncogenes are responsible for producing cancer. So proto-oncogenes do not cause cancer, but oncogenes, which are their mutated forms, do. Question number 3 says that when a reaction A goes to B is at equilibrium, there is more B than A. What can you say about delta G 0 prime? Well, let's remember first of all that delta G is equal to delta G 0 prime plus RT times the natural log of products over reactants, which in this case would be the concentration of B all over the concentration of A. Now, the key here is it says that the reaction is at equilibrium. So at equilibrium, delta G equals 0 equals delta G 0 prime plus RT times the natural log concentration of B over the concentration of A. Now, if we have more B than A, that would mean that this guy is in greater amount than this is, which would mean that the ratio of B to A would be greater than 1. And the natural log of a number greater than 1 is a positive number. So this whole term on the right would be a positive number. Well, since the delta G is equal to 0, that means that the sum of these two things on the right must be equal to 0, which means that delta G 0 prime would be a negative number of the same magnitude as that of the RT natural log term. Question number 4 says, when a reaction A goes to B has delta G 0 prime equals 0, and there is more A than B, what can you say about delta G? Well, we go back to our same problem, and we say delta G equals, in this case, 0, because we said delta G 0 prime is equal to 0, plus RT times the natural log concentration of B over the concentration of A. In this case, there's more A than there is B, so this ratio of B to A would therefore be less than 1, which would mean that the natural log term would be negative. Well, this is negative plus 0 is going to equal a negative number. Delta G would also be negative as a consequence. For question number 5, the problem says that when A goes to B, and there's more A than there is B, what can you say about delta G 0 prime and delta G? Well, we plug into our equation, delta G equals delta G 0 prime plus RT times the natural log of the concentration of B all over A. We know that A is greater than B, so we know that this natural log term is negative. However, that's all that we know because we have two unknowns. We don't know anything about delta G. We also don't know anything about delta G 0 prime. As a result of this, this equation is not solvable because any equation with two unknowns in it and only one equation can't be solved. So problem 5 can't be solved.